Hello everyone, Dev Victoria is here, and in this video I am going to continue examine the physics samples character controller, because now what we have to figure out how to handle the collisions, and obviously in these samples the collisions are handled perfectly. And I am also going to show you how the physics velocity is calculated for this character. So let's go to Visual Studio Code and let's check the code. There is a character controller system in the character controller outdooring CS file, and this system is what moves the character. And how does it move? It calculates the physics velocity just like we did before. And also what it does, first it checks for the support, whether or not the character is standing on a surface or just falling down from some platform. This check support is in the character controller utilities CS file. I am not going to go in detail what it does, but you can take a look at this. But what is important thing is that it gives us the surface normal and the surface velocity, and also the supported state. And then we are going to handle the user input. The handle user input it is in this file, and basically it calculates the linear velocity strictly based upon user input, and also it considers if the character is supported or not, or if the character is about to jump or something. So, but this method is basically calculates the linear velocity based upon the user input. And then we got this calculate movement method. This calculate movement method is going to make sure that the character is moving along a surface if it's supported. Like, for example, if a character moves up or down on a ramp, then it considers the ramp's tangent to make sure that the character moves alongside the ramp. And also it considers the surface velocity. For example, if the character is on an elevator, then it combines this surface velocity to the linear velocity. This received input from what we had calculated before, and outputs an updated linear velocity. And then once is done, the collide and integrate method is going to calculate with the collisions. And this is also in the character controller utilities. Okay, now let's take a look at this collide and integrate method then. So it receives a bunch of parameters. The most important thing is this linear velocity, which is this is going to be updated. First, we are going to save this into a new velocity, and a couple of lines later, this is what we are going to write back to this linear velocity. So the goal is to take the colliding into consideration and update the linear velocity what we have calculated before if necessary. And what we are going to do, we are going to just slice up this time, and then each slice we are going to check what is going to happen. First, we are going to do a collider cast, and based upon the colliders that this collider cast found, we are going to create constraint. And I would like to remind you guys for one thing. In this character setup, the collision response is set to none. So basically, this character controller is going to calculate all the collision events and trigger events if these checkboxes are checked. And also this is going to be responsible the calculating all the collisions as well. It is very important to have these things in mind because these calculations are in this code as well. So, but first we are going to create constraints for the colliders we had found, and right here, if this trigger events is created is checked, then we are going to update the trigger scene. I am not going to go into detail in this method. If you are interested in this, then please leave a comment below and maybe later I'm going to do a video about that. The next thing that we are going to create a distance heat query, and we are going to go through all of these distances, and then we are going to update the constraint information based upon this distance heat. Basically, this is, as the comment said, it is for discovering penetrating heat and updating the constant constraints with this penetrating heat, just in case it's something it hasn't coded by the collider cast. We are going to add this here. And basically, these constraints that we had created is a surface constraint info. This is in the Unity Physics namespace, and it belongs to this simplex solver class. And we are going to create these constraints so we can use this simplex solver solve method. And this unfortunately is not commented, but this, if my understanding is correct, is going to update the new velocity we have here based upon all of these constraints. So for example, if our character is colliding with a wall that is right in front of it, then it might move the character sideways if it can, for example. But in our case, I don't really need this complexity. Obviously, this is like a hyper super cool character controller, so this is very complex. In my case, I'm not going to do this sort of complicated things. But it's good to know that you can use this simplex solver solve method in order to get a precise character movement velocity. And yet again, if we have to calculate with collision events, or we have to affect bodies, then this calculate and store deferred impulses and collision events is going to do that. Yet again, I'm not going to go into details what this method does, but if you are interested, let me know in the comments below this video. And finally, we are going to calculate a new displacement. And basically, we are going to calculate here if the character can move to a new position. So we are going to cast a collider in this new position. Yeah, this is the new displacement. So the pref position plus the new displacement is the new position. So it would be better if the new position would have been written here, but that's fine. So we are going to cast the collider and we are going to get the closest hit. Based upon that, we are going to calculate the new position. We are going to write this back to the transform position. And also we are going to reduce the remaining time. And finally, we are going to write back the new linear velocity to the character's linear velocity. So once we done all of this, then we are going to update the collision events and the trigger events, and we are going to write back the position and the rotations value, and also we are going to update our internal data for the character movement. Basically, this is the end of the character movement calculations. As I mentioned before, I don't need this complicated calculation, but I guess there are some takeaways from this, and for me, what is interesting is this last part that we are calculating a new position for the character, and practically we can check if we can move there to this new position. It won't cause any problems. And actually, this is what I'm going to implement in my character controllers because I don't need calculate it with slopes simply because my character is going to move on a flat surface. And also for me, if a character hits a collider, it's perfectly fine if it just stops. So if the character cannot move to a new position, then it can just stop. And when it can move to a new position, then it is going to move. So this kind of simple behavior is going to be enough for me. So this is what I'm going to implement, but that should wait till the next video. And I hope you enjoyed this one and perhaps learn something from it or get some inspiration from it for your own project. Please leave a comments below about this video and see you in the next one. Goodbye for now.